This next graphic is illustrating how the soil textural class changes or influences the available water content stored in a given soil. We're graphing soil water content on a volumetric basis from 0 up to a high of approximately 36 or 7%. We're looking at field capacity values on the top line of the graph, and we're looking at the Wilding coefficient on the bottom axis or line on this graph. The total amount of water held would be between field capacity and down here at the bottom of the graph. Some of that would be available, some would be, of course, below the Wilding coefficient is considered unavailable water. Our first soil textural class illustrated on this graphic is a sand or very coarse textured soil. In a very coarse textured sand, we may only hold somewhere around a little less than 8% of the total soil volume may be water at field capacity. At the Wilding coefficient, we're probably looking at 1% or less of the total soil volume being occupied by water in the sandy or coarse textured soil. So the difference between field capacity and Wilding coefficient is available water, and you can see in a coarse soil, even in a sandy loam, that is not a very large amount of water. As we progress into the loam and silt loams, or the medium textural classes, we see a higher level of water held at field capacity, and of course a higher level of water also held at the Wilding coefficient, but the difference between field capacity and Wilding coefficient is much larger. Actually, in a silt loam soil, the amount of water held between the Wilding coefficient and the field capacity is actually the greatest. So in loam to silt loam types of soils, we have a greater amount of total available water held between field capacity and Wilding coefficient. Now, as we progress into the finer textured soils, we see that our field capacity graph is still going up. We're having more water held at field capacity in the fine textured soil than we do in the medium textured soil, slightly greater amount. But the Wilding coefficient is correspondingly higher also. So due to the fact that the available water is that held between field capacity and the Wilding coefficient, even though the fine textured soil, like a clay loam, will hold more total water, it actually holds less total available water. Remembering that total available is defined as that held between field capacity and the Wilding coefficient. So we can use this particular graphic to illustrate why medium or loam to silt loam textured soils will actually hold the most total available water. And it is due to the fact that even though they don't hold as much at field capacity as the fine textured soil, they hold correspondingly less at the Wilding coefficient than do the fine textured soils, and therefore total available is actually greater over here in the loam textural class than it is over here in the clay loam textural class. So from this graphic, I'd like you to take away 2 points. Field capacity goes up as the soil textural class becomes finer, and the greatest amount of total available water is held in loam or silt loam soils, in contrast to those that are finer textured, such as the clay loams or clay soils. And 2, the reason for that is because we have a higher level of water held at the Wilding coefficient in the clay soil than we do the loam soil. Even though it holds slightly more at field capacity, this higher amount held at the Wilding coefficient more than offsets the fact that it holds a slightly greater amount of water than the loam soil at field capacity.